Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Muhammad Daniel bin Syed Mazam, and today I'm going to present about my final year project. And my title of my final year project is The Influence of Road Geometry on Flash Flood Incidents. So flash floods are one of the most catastrophic natural hazards in many areas of the world, causing significant losses on a yearly basis, particularly in the city. So road infrastructure remains particularly vulnerable to such an event. This is according to Diakakis in his research in 2020. So urban flooding occurs when the capacity of both natural and drainage system is insufficient to handle the volume of precipitation and also the runoff discharge within an urban area. So therefore, the precipitation water is utilizing the road as a channel for discharge, and this is according to Gaitan in his research in 2016. So the objective of this study is to investigate the road geometric characteristic that contributed to flash floods in Kuala Lumpur in 2022, and also to evaluate the road's vulnerability to flash flood incidents. So the problem statement of this research is the number of flash flood incidents in Kuala Lumpur is constantly high, as well can see in the graph. From 2011 up to 2022, there are at least 10 floods, except in 2012. So in 2011 there are 12 floods, in 2012 there are only 1 flood, 2013 there are 13 floods, and for 2014 14 floods, 2015 10 floods, 2016 13 floods, and 2022 there are 10 floods. So the next problem statement is flash flood cause significant direct losses, such as property damage and human injury, and growing indirect effects such as disruption of public service and economic activity. So moving forward to methodology, and this study is a case study type of research. So the following flowchart will be applied in this study. So I'll be starting with literature review, and I'll carry on with data collection. So for data collection, all the flash flood incidents in Kuala Lumpur in 2022 will be collected, and the data collected includes the date and time of the incidents, the road affected, the intensity and duration of the rainfall, and the temperature of the day. From all the data that was collected, a database was created in Microsoft Excel, and this data will reveal the roads that are prone to flash flood, in which where we will be survey the road, survey the road geometry of the roads. So moving forward to data analysis, to analyze the vulnerability of the roads associated with flash flood incidents in Kuala Lumpur. So the data that have been collected was sorted based on the frequency with which the flash flood occurred on a particular road. So the roads that are prone to flash flood were then discovered, and the geometry of the roads were studied. And the geometry parameter includes the number of lanes per direction, presence of shoulder, presence of roadside drainage, median, and distance to the nearest water body. So with all the data collected, the influence of road geometry on flash flood will be determined through descriptive analysis and also multinomial logistic regression analysis. So the last step is the outcome, where this study will produce a regression model of flash flood vulnerability with respect to the road geometry parameters, and this model could be used to predict flash flood on certain roads. With this, when the rain pours on the Kuala Lumpur, local authority can take precautions to divert the traffic from the roads that are predicted will be flooded. So for instrumentation, there are actually 3 instruments that I'll be using. First one is Google Map, where I'll be using it to survey the road geometric road characteristic of the particular road. The next one is Microsoft Excel, where I'll be creating database in this Microsoft Excel. And last but not least is the IBM SPSS statistic, where I'll be carrying out my data analysis, which is descriptive statistic and also multinomial logistic regression. So moving forward to the results of this research, the summary of data collected, there are total number of 10 flash flood in Kuala Lumpur in 2022, and total number of roads surveyed is 65. Sorted data of road characteristic and number of road flooded and not flooded. So there are 4 variables, which is lane per direction, drain, curb, and median. As for lane per direction, the minimum number of lane per direction is 1 and the maximum number is 5. As for drain, curb and median, 0 is without drain, curb and median, 1 is with drain, curb and median. So the result for multinomial logistic regression of flat, the compared group is 0 flat, 1 flat and 2 flats, and the reference group is 3 flat. So the number that shown in the table is the coefficient of the group. So from the coefficient, we can the data can be interpreted as the coefficient of distance to water body is positive for the 3 compared group. So this indicates that the bigger the distance to water body, the tendency for 0, 1 or 2 flat is more likely compared to 3 flat respectively. So as for the number of lanes per direction, the negative coefficient for the 3 groups indicates that with the high number of lanes per direction, 3 flats are more likely to happen when compared to 0, 1 and 2 flats. The multinomial linear regression result shows that with the absence of roadside drain, the road is prone to 3 flats compared to 0, 1 and 2 flats. This is proved by the negative coefficient of all 3 comparisons, which are negative 3.636, negative 2.815 and negative 4.725 respectively. And last but not least, the coefficient of road curb and median are both positive. Thus it shows that without road curb and median, compared group which is 0, 1 and 2 flat are more likely to happen when compared to 3 flats. So the conclusion of this study, from the multinomial logistic regression, I can conclude that distance to water body, lanes per direction, roadside drain, roadside curb and median affect the vulnerability of the particular roads to flash flood incident in Kuala Lumpur for the year 2022. That's all from me. Thank you so much for listening.